Okay. Should be recording. Just a little note. I forgot to divide on the last part because it is V over R, not V times R. I was just typing, so I just kept going straight. But yeah, so you're supposed to divide that and everything else should be fine. Anyway. Thankfully, I had drawn this one out earlier, so got it here. In this equation, we're going to be using the Kirchoff's rules. So just a reminder of what those are. You have the loop rule. So you have the junction rule. You have the loop rule. And this isn't technically Kirchhoff's, but is important. Signs and directions. So okay. The junction rule says that everything that goes into a junction, current wise, that's really thick. Is there a way to make that thinner? There's not. Should be the same as everything that goes out of the junction. So say for this one, we have, I guess maybe two junctions, that I can see would be like here and here. But they're kind of the same, so we'll probably end up picking only one. We also need to pick, our loops and which way they're going. So, probably gonna need at least 3 currents. Probably go. Go like this. Because this one's gonna have to go the same direction. The central one. Yeah. Well, let's look at the signs and directions and then pick which direction would go best for us. So if we were to have a resistor, I should have written that lower. We have a resistor, or we can have, I guess technically the battery. If we're going, oh, for a resistor, we're saying I is that way. If we are traveling this way, then we're gonna have a traveling with is gonna be negative V. And if we're traveling against the current, we're gonna have our positive V. And this is I. And then for the battery, if you're traveling from negative to positive, it's gonna be positive V. And if you're traveling positive to negative, it's gonna be a negative V. That one's a bit easier to remember because it's just whichever side you ended up on. So remember that the little one is the negative and the big one is the positive. And then we have our loop rule, which says that all of the voltages in a loop should equal out to 0. So using that information, now let's pick. Oh, wow, you're gonna make me do that. We'll just stick with what we have then. So we'll go ahead and start assigning signs since I already wrote out the direction. Here we're going from positive end, negative end, which means that this is going to be a positive, negative V. Negative V. I don't think she should have told us which direction the currents are running in. She does not seem to tell us which way the currents are going. Hmm. Okay. I would probably guess that the currents are going to be going this way. And then this one's going to be going this way. My reason for that is because it's going to be moving from the negative, which is where your electrons are, to the positive. I do remember there being like the convention being weird to me, sense-wise, so it might be the other way. But we'll stick with this just for the purpose of the problem. Which she usually should tell you. Anyway. So then if it's going that way, and that means that the center one should be going down because it's going to need to be going out. We'll call this 1, 2, and 3. And if we use our junction rule, we're going to say that this one's going in, which we're going to be our 1 and 3. So are going to equal to the one going out, which is your I2. And then we can go ahead and continue with labeling stuff. So because the 3 is going that way, then this means that the current's going to be passing through here, and our loop is going opposite of that. So that's going to be a positive U. And I'll just go ahead and put IR for now. Because we're going to be needing to use the IR. And then for this one, our current is going to be going through like that. And again, our loop is going opposite, so this is also going to be positive. And then for this one, we've got it coming down this way, our current, but our loop is going opposite, it's also going to be positive. That's kind of nice. And then for this one, this is going with the current. So that one's going to be what, negative? Yeah, no, because our direction of travel is going this way, downwards. So that's going to be negative D. So we've done our junction rule. Now we can do our loop rule. We're going to be going around this loop. I guess we can probably start with a 0 is equal to. We have we'll start with this one, this 4 ohm one. That one is going to be multiplying onto the second current. So I2 times 4 ohm. And that one's gonna be positive. So we're not gonna need to write the sign. Then we're going through this 3 ohm resistor, which again is gonna be positive, so. And that should be I1 at that point. Because we hit this junction and that I1 is running throughout this entire half, this entire side. And then that's 3 ohm. And the other thing that we have in that loop is this battery, which is gonna be our negative 12 volts. And we'll go ahead and do the next loop. We'll start in the same space, starting from here and then going down and out. So it looks like the I2 is probably gonna be the same. And then we have this 2 ohm one, which is running on the third current, so I3. And that one's a 5 volt battery, so -5 volts. And then from here, it's algebra. We're gonna have to plug things in and try and substitute to figure out what our currents are worth. So let's see. Could plug in our I2 and we'll get these. Could also equal these two to each other. And then we'll still have our I2 and I13 though. Volts over. That one there. Good 2 and 1. Not what we want. I'm probably, I think this one will probably need like a triple substitution, where we like isolate the I1 and I3 and then plug it into this top equation. So that's what I'm gonna try to do. We'll move our 12 volts over. And anything with the I2 over. Minus. I'm just gonna start writing the 4 as is. I'll write the 4 ohm for now. It's already set it up. And the next one, I'll just have the 4 in front, just because it's a bit faster to write. I'm also gonna go ahead and divide by these. I don't want to take up a ton of time writing everything out. That's why I'm trying to do everything all in one swoop. Okay, mhm. One for the top one. 3 for the bottom one. And then we're gonna go ahead and substitute those into the top equation. So then it's gonna look like a big problem. 12V minus 2. Oh, I said I was going to do the 4. So yeah, I'm gonna just put the 4 up front. Divided by 3 ohm. I guess I could put the 4 in the back. And then plus I3, which is 5 volts minus 1, 2 over 2 ohm. Go to our I2. And we're gonna go ahead and solve for I2, which would probably start by doing this. 2. That allows to combine things. I'm gonna start also just distributing this into there while we're at it. Three minus 8, 2. This can be over 6 ohms, and they're gonna combine. So I'll just go ahead and combine it. Plus 5 times 3 is 15 volts. 3 is 12. 2. 2. We can go ahead and add the 24 and 15 volts. They used to go together, and they used to go together. And then we're gonna separate them so that they're on their own fractions, just so it's easier. So it's gonna be 39, 9 volts, 6 ohm. And then that should probably be negative because both the i's are negative. So you're gonna add two negatives to get a negative 20. I2 over 6 ohm to I2. Now go ahead and move this one over and then simplify this. So 39 divided by 6, about 6.5. Could also probably simplify this one down a little bit. I'll leave it as is actually. Plus. Which that's basically the same as I squared. 1 plus your fraction. Remember that the 8 and the 12 were already ohm, so this 20 is also ohm. So then this fraction is just going to be unitless. Because this one had an ohm and this one had an ohm there. It's gonna get us Equal to, we're gonna divide this one out. So that's gonna give us 6.5 volts over 1 plus our 20 over 6. And then go ahead and let your calculator sort that one out. 6.5. 1 plus 26. I got 1.5. And this should probably be ohms here. So that will be amperes. And then the next substitution should be a bit easier. You're gonna plug in that I2 to either of your loop rule equations, and then you're gonna plug all of those into your junction rule to find the last I. So let's go ahead and do that. I'm gonna go ahead and pick this one just because it seems it's got a lower voltage. We'll just put it there. Okay, so 0, 2. This is our I squared, and we just found it, so we're gonna go ahead and put it in. It's 4 ohms. Plus I3. Oh, we had already isolated for I3. So we'll actually use this one over here. Can you move stuff around? See if we can fit the 5 volts over here. Volts. And that's gonna be divided by our 2 ohms from the next to the I3. Go ahead and let our calculators handle that. Minus 1.5 times 4. All of that divided by 2. 0.5 ampere. And then put that into I1 plus I3 is equal to I2. That one could probably get rearranged into is equal to I2 minus, we solved for I3, I believe. Yeah. Two. Right. Negative 0.5. So that's going to give us 2 ampere. And then we've solved for all of our i's. So yay. All right, thank you guys for coming and for staying. Those were the problems I had for you guys today, and I hope you have a nice day. You guys have any questions before we leave? Cool. Thank you. Welcome. Have a nice day and good luck on the exam when you guys do have it.